In this video, we are going to see about introduction of compiler and the structure of a compiler. Let us start with the compiler introduction. Compiler is nothing but is a translator or software which is convert a program written in one type of language, that is high level language, into another type of an equivalent language, that is low level language. Low level language is called as object language or target language or machine level language, and high level language is also called as source language or source program. It is a diagrammatic representation of compilation process. It converts high level language into low level language. So high level language is nothing but which is understandable by the human, and it is readable by the human, but low level language is understood by machine. It is only understood by machine. During compilation process, the compiler produce error to the programmer. These are some of the difference between high level language versus low level language. So for high level language, it is very easy to learn comparatively low level language, but in low level language it is somewhat difficult to learn, and high level language is human readable and human understandable language, but for low level language it is machine readable only. So for high level language, there is translator is required to convert the given high level language into low level language, but for low level language there is no translator is required, because the language is already in the form of low level language, which is readable or understood by the machine. So there is no translator is need. So in programs in high level languages are slow in execution, but for low level language the execution speed is fast. These are an example of high level language, assembly level language and machine level language. So for high level language, let us take the example C is equal to A plus B. It has the operation of addition, so we have to add the value of 2 operand and the result stored in the another variable C. So it is it is very easy to understand and readable by the human. This is because this is high level language. So some of the example for high level languages are C, C++, Java and Python. There are multiple high level languages are there. So to convert the given high level language statement into assembly level language by an assembler, assembler is also an translator. So this addition operation can be written as by using mnemonics add and add a comma b. So this is assembly level language. And final one is machine level language. Machine level language is low level language. It is the combination of zeros and ones, that is binary language. So the statement or instructions can be written in the form of combination of zeros and ones, that is 100, 100, 111. So this is machine level language. So by using compiler, the compiler convert the high level language C is equal to A plus B into machine level language, that is low level language. Here the assembly level language and machine language or low level language. C is equal to A plus B is a high level language. So both assembly level language and machine level language are low level language. So compiler is a translator that converts the high level language into machine level language. It is used to show the errors to the programmer, and the main purpose of compiler is it have to change the code which was written in one type of language to an equivalent another type of language without changing the meaning of the program. This is the main purpose or scope of the compiler. There are two parts in compiler. In the first part, the given source program is compiled and translated into an intermediate representation, that is low level language, and in the second part the object program is converted into target program by using the assembler. This is the first part and second part. So in the first part, the high level language C is equal to A plus B is converted into add a comma B, right? This is the first part. In the second part, add a comma b is converted into 100, 100, 111 machine language by using an assembler. So the first part is performed by compiler, high level language into assembly level language. So the second part, that is assembly level language into machine level language, is performed by the translator of assembler. So the first one is compiler, second part is performed by the assembler. So the compiler can be divided into two phases or two parts. The first one is analysis phase and the second one is synthesis phase. So first of all, we will see the diagrammatic form. So for compiler, it converts the given source code into machine code. So there is some intermediate code representation. So the first part, that is analysis, is used to convert the given source code into intermediate code. This part is referred as analysis part, and it is also called as front end of the compiler. So in the second part, that is synthesis part, which is used to convert the intermediate code into the machine code or low level language. It is also referred as back end of the compiler. So the first part is analysis phase. It is the front end of the compiler. It is used to generate an intermediate representation of the source program. So the second phase is synthesis phase. It is also known as back end of the compiler. It generates the target program. So the compilation process is the sequence of various phases. Each phase take input from the previous stage and produce the output to another stage as a input. Let us understand the phases of a compiler. So the phases of compiler starts with the overview of general language processing system. It is a concept of processing of language, any language. So there are four important points. One is preprocessor, compiler, assembler. The final one is loader or linker. So initially the preprocessor getting the skeletal source program as input and produce source program as output. So skeletal is nothing but it is a piece of source program. There may be multiple modules or multiple pieces of the given source program. So by using preprocessor, it combines all pieces or all modules of the given source program into the whole one. So the preprocessor produced the source program as a whole. Then the source program gives us input to the compiler. Here compiler and assembler is a translator. So the compiler convert the source program into assembly level language. Already we saw the example. For example, compiler convert C is equal to A plus B into add of A comma B. That is the aim of compiler. So the compiler produce assembly level language or assembly program as output. So which was given to the input of assembler. Assembler is another type of translator. So it also convert the given assembly language into low level language, but it is relocatable machine code. The meaning of the word relocatable machine code, here the machine code can be placed in any location, that is relocated. So we have to link all the machine code which are placed in various location by using linker. So the concept of linker is which is used to link all the relocated machine code into the single place, single location by using the linker. And finally the loader. Loader is used to load the program into memory for execution, because whenever the code or source program or a language which is going to be loaded into memory before execution, so the purpose of loader is which is used to load the program into main memory for execution. Finally the output absolute machine code is produced by loader or linker. So this is the common processing system for any type of language. So what is preprocessor? Already we saw preprocessor which is used to produce input to compiler. There are four main functions in preprocessor. First one is macro processing, file inclusion, rational preprocessor, and a language extensions. So macro processing is used to define macros, and file inclusions used to include header files. Header files is nothing but, for example, hash include stdio.h. This is done by file inclusion. And a rational preprocessor, this processor includes the older language with flow of control and data structuring facilities. And final one is language extensions, which is used to add capability to any type of language by using built-in macro. These are the four functions which are performed by the first one, preprocessor. So the second one is compiler. Already we saw compiler convert the high level language into machine level language or low level language. And the third one is assembler. Assembler get the input from compiler of assembly language program and produce the machine level language as a output. So it convert the assembly level language into machine level language, because assembler is also an translator. The next important point is interpreter. So interpreter is also a translator, which is also convert the high level language into machine level language. So input is source program and output is target program or machine level language. So these are the difference between compiler and interpreter, because both compiler and interpreter are translator. So for compiler, it takes the whole program as input, but for interpreter, it takes line by line, single instruction as an input at a time. And for compiler, intermediate code is generated, and for interpreter, there is no intermediate object code. And compiler executes very faster, interpreter executes very slower, because it takes instructions one by one, so it will be slow. And for compiler, the memory requirement is very high, and for interpreter, it takes less memory requirement. And for compiler, each and every time the program have to be compiled, but in interpreter, the higher level language is converted into low level language. And for compiler, the errors are displayed after the entire program is compiled or checked, but for interpreter, the errors are displayed for every instruction is executed or interpreted. So for example of compiler is C compiler, and for interpreter the example is BASIC. The main point is interpreter takes single line or single instructions at a time, but for compiler it takes entire program as an input. So the loader, final language processing system loader, takes the program and loads into memory for execution, because the purpose to produce the absolute machine code. So the structure of the compiler design, it is done by phases of compiler. Compiler operates in various phases. A single phase take an input from the previous phase and produce the output, which was the input of the next stage. And finally the compiler produce the machine level language. The compiler have two parts, one is analysis part and the synthesis part. The analysis part is machine independent, but for synthesis it is machine dependent. The compilation process is partitioned into the number of sub phases or number of sub process, which is called as phases. The compilation process is partitioned into number of sub process is called as phases, right? So for compiler, it converts one type of language into another type of language. So for that process, which have to be divided into number of sub process, each process known as a phases. So there are 6 phases in compiler. Each phase help in converting the high level language into the machine level language. The first phase is lexical analysis phase, and the second phase is syntax analysis phase. Third one is semantic analysis phase. Fourth one is intermediate code generator. Fifth one is code optimizer, and last one is code generator. So this is the diagrammatic format of phases of compiler. So the high level language is converted into assembly code or machine level or low level language by using 6 phases, and all these 6 phases are interacted with a symbol table and error handling. You can clearly see that all 6 phases thoroughly interacted or contacted with the symbol table and error handling each and every single phase. So let us start with the lexical analysis phase, which is the first phase of the compiler, and it is also called as scanner because it is used to scan or read the source program from left to right, and it can read or scan the character one by one. It can read one character at a time to identify the token. So the lexical analysis read the source program, read the part of the source program from left to right to identify the token for the corresponding lexeme. I am using 2 important terms, one is token and a lexeme. For example, taking integer a comma b, here int is a lexeme A is a lexeme, B is a lexeme, but we have to identify the token for this lexeme. So int is a keyword, right? We can't rewrite it as int1 in1. So it is a keyword, it is a built-in keyword. So int is a keyword. So here int is a lexeme and keyword is a token. And a comma b, a is an identifier, b is an another identifier. So a is an lexeme and a is an identifier. Identifier is a token, right? And also same thing, b is a lexeme. We have to identify the lexeme. B is an identifier, so identifier is a token. So in this lexical analysis we have to identify token and lexeme by using some patterns, right? So there are some functions to be performed in lexical analysis phase. It is used to identify the lexical unit and it have to be identify the token. So the lexical units can be divided into constant, reserved words, keywords, operators, assignment operators, etc. Let us take an example. X is equal to y plus 10. This is the part of the source program, which means it is a line of the source program. So the lexical analysis read or scan the part of the source program from left to right. First of all, the lexical analysis read the single character X only. So X is a lexeme. Each and everything is a lexeme. X is a lexeme, is equal to symbol is a lexeme, y is a lexeme, plus is a lexeme, 10 number is lexeme, right? After 10 there is semicolon, so semicolon is also the lexeme. So we have to identify the token for the corresponding lexeme. X is the identifier, so identifier is a token. Is equal to symbol is an assignment operator, so assignment operator is a token for the corresponding lexeme equal symbol. Identifier is a token for the lexeme y. Addition operator is a token for the lexeme plus. Number is a token for the corresponding lexeme 10. So the second phase is syntax analysis phase. It is a second phase. It is also called as parser, which is mainly used to construct the parse tree from the token received from the lexical analysis phase. So here the list of tasks to be performed in this phase. First point is syntax analysis get the token from lexical analysis, because the lexical analysis aim is to identify the token. So the syntax analysis get the token from lexical analysis. Second task is check the expression is syntactically correct or not, and if there is any error means it should report the syntax errors. After that, the syntax analysis phase construct the hierarchical structure that is known as parse tree or syntax tree. Let us take the example a plus b star c, right? This is a statement part of the source program. So we can easily draw the parse tree or syntax tree for this source program. Here star is an root operator, and star having two children. One is a plus b and another one is c. So we can write the rightmost child c, and after that the leftmost child for star is a plus b. So here also plus having two child, one is a and another one is b. So we can take it as root of plus, and left child is a and right child is b. So from this diagram you can clearly see that interior nodes are operators and exterior nodes are operands. Interior nodes are star and plus, and exterior nodes are a, b, c. That is operand. Operand is nothing but a variable or identifier. And third one is semantic analysis, which is mainly used to check the meaning of the source program. So it is also used to perform type checking operation. Let us take the example. Float x is equal to 20.2. Float y is equal to x multiplication 30. Here 30 is an integer number and 20.2, that is x value, is float. So we can't multiply the float number into integer number. So before performing the operation of this statement, the semantic analyzer perform the type checking operation by using typecast operator, which means we have to convert the integer number 30 into float value before multiplication. This operation is done by the third phase of compiler, that is semantic analysis phase. And the fourth phase is intermediate code generator. It is used to generate the intermediate code by using a temporary operator. Let us take the example, total is equal to count plus rate star 5. This is the part of the source program. So by using intermediate code, it convert the part of the source program into intermediate code by using temporary variables. So you can clearly see that T1, T2, T3. So these are the temporary variables. Temporary variable 1, temporary variable 2, temporary variable 3. So first of all, we have to assign T1 is equal to, we can convert the integer number 5 into float value. So T1 is equal to integer to float. From this point, we have to convert the integer value 5 into float value. So T1 is equal to integer to float of 5. After that, the 5 value is assigned to T1. So we can take the another temporary variable T2. T2 is equal to rate star multiplication T1, because already the number 5 is assigned to T1. So we can write it as T1 for 5. After that, taking another temporary variable T3 is equal to count plus T2, because T2 assigned for rate multiplication 5. So finally, the whole value T3 is assigned to total. So this is the concept of intermediate code, which was generated by the fourth phase, intermediate code generation phase. And fifth phase is code optimization, which is used to optimize the code. The word optimization is nothing but improvisation, which is used to improve the quality of the source code. The primary functions of this phases are, it helps to establish a trade-off between execution and compilation speed, and also it improves the running time. It used to removing the unreachable code, and it is used to removing the statement which is not altered from the loop. So these are the functions to be performed by code optimization to improve the quality of the source code. Consider the following code. A is equal to into to float 10, and B is equal to C multiplication A, D is equal to E plus B, F is equal to D, which can be rewritten as B is equal to C multiplication 10.0, because the value for A 10 can be converted into integer to float. So that is nothing but 10.0, which was assigned to A. So directly we can assign the value for A. So B is equal to C multiplication 10.0. And the last one is F is equal to D. So for D, we can write directly E plus B. So the above 4 line can be rewritten by using the 2 line. So this is the concept of code optimization. We improve the quality of the code. Improvisation means we can decrease the running time, execution time, and decrease the cost. These are the concept for improve the quality of the source code. And the final one is code generation, which was the last phase of the compiler, which is used to convert the given code into the final target code. Let us take the example. A is equal to B plus 60.0. It can be converted by move. We can use the operation. Move is nothing but move, multiplication, mul, add. These are the mnemonics. It is the assembly level language. Already I said assembly level language is also low level language. So move F, we can using one letter F, because in the above statement 60.0, that is a float value. So for performing float operation, here we are using F, move F. So first of all, we are going to move the value of A into another register R1, and then performing multiplication operation 60.0 comma R2. Here 60.0 is a constant value, so we can write hash value before that constant value, and finally we can add the value of R1 and R2. So these are the concept of assembly level language. So the above 6 phases are completed, and in the first diagram I said that throughout 6 phases, symbol table and error handler concept is conducted with all the phases. So symbol table is nothing but it is a data structure which is used to store the value, store the information about all identifiers which are identified in the source program. Symbol table is a data structure which containing record for each and every identifier which was identified in the source program throughout all the phases. And the final one is error handling, which is nothing but each and every phase can encounter some errors. So each and every phase can have correct the error, then only we can move on to the next phase. So for lexical analyzer, it can identify the wrongly spelled tokens. For syntax analyzer, it have to identify the missing parenthesis. For intermediate code generator, it have to identify the mismatched operands for an operator. For code optimizer, it have to identify when the statement is not reachable. For code generator, the unreachable statements have to be identified. So these are the example. This is the example for phases of compiler, which is used to convert the high level language into assembly level language. So the given part of the source program is sum is equal to old sum plus rate multiplication 15. It is a part of the source program. In this example, we are going to saw about how the single statement can pass through all 6 phases, and what is the output for each and every single phase, and how the each and every phase can performed by taking the input from the previous phase, and finally produce a target program. So there are 6 phases. So the first phase is lexical analysis phase. The purpose of lexical analysis phase, which is used to identify the token for the corresponding lexeme. So here sum is one lexeme, sum is one identifier, old sum is another identifier, and rate is another identifier. So we can write it as id1 is equal to id2 plus id3 star number or number 50 number. So it can pass to syntax analysis phase. Syntax analyzer is nothing but generate the parse tree or syntax tree. So the root value is equal symbol which can be assigned to the leftmost children id1, and plus we can write take the symbol plus. So for plus, the leftmost child is id2, and for plus the rightmost child is id3 star id4. But for id3 and id4, it having the root operator star. So star having left children id3 and right children id4. So it was produced by syntax analysis phase. It is passed to semantic analysis, that is third phase. So for third phase, it is used to check the meaning of the source program, which is used to perform typecasting, type checking by using the typecast operator. So the same syntax tree is presented in semantic analyzer. The change only in syntax analysis is have to perform in the type checking. That is 50, number 50 is converted into integer to real. So it can be given to the input of intermediate code generator. It was generated by using temporary variables. So the temp1 is equal to assigned to integer to real value 50. Then temporary 2 is equal to id3 multiplication temp1, and temporary 3 value is equal to id2 plus temporary variable 2, and finally the temporary 3 values are assigned to id1. So which is given to the input of code optimization. So the main aim of code optimization is improve the quality of the source code by reducing the unwanted statement, repeated statement. So the first statement temp1 is equal to id3 into 50.0. So id1 is equal to id2 plus temp1. So you can clearly see that the intermediate code generator produces the same intermediate code, but it having 4 lines. But by using code optimization, it produces only 2 lines. So the execution speed is very high. So this is the improvisation concept. Finally, it can given as the input of code generation phase. So for code generation, initially the id3 value is moved to another register R2, and which was performing the multiplication operation with the constant value 50.0. Here all mnemonics perform floating point value, so that's why each and every mnemonics having f at the end of the mnemonic. And for constant value, we have to put the symbol hash before the constant value. And next third line is move F ID2, R2, the identifier value is moved to another register and perform addition operation with R2 and R1. Finally, the R1 register value moved to ID1. So this is the concept of phases of compiler. So in this lecture we saw about what is compiler, what is translator, what are the types of translator, compiler, assembler, interpreter. These all are the types of translator. Translator is nothing but which converts one type of language into another type of language, right? Compiler converts the high level language into assembly level language. Assembler converts assembly level language into machine level or low level language. So there are we saw about the differences between compiler and interpreter. Compiler compiles the whole program, but interpreter take the one instruction at a time and perform some process. And there are 6 phases, and lexical analysis is used to identify the token for the lexeme. So symbol table is nothing but it's a data structure containing a record for all identifiers which are identified in the source program.